Good afternoon, viewers of the DP Labs channel. My name is Kirill. Today I'm going to tell you about our new project. It's an electric ATV, just the way we like it, but built on a completely different principle. Let me briefly explain the concept. We will be making it out of sheet metal, and the architecture will be fully tailored for electric technology. We have a kind of backbone frame. It's formed from a rectangular section of sheet metal. All the electrical and mechanical components of the ATV are housed inside it. On the outside, the control arms and all other elements that extend beyond the sealed capsule with the electronics are attached. Next, I'll tell you about our concept and how it evolved from the original idea. The original idea, right in front of you, is a functional unit that contains wheels, drives, motors, batteries, and steering. In other words, it's a fully ready, standalone component. A person can use it as a motorized tow or as a drive unit for some small agricultural machinery, for example. After starting to carefully develop the project, selecting the necessary components and so on, we found several important points that made the overall concept just slightly impractical. We tried to play with the idea from the start, as you can see on the monitor. That is, let's say two carts are assembled, some kind of spacer, and this is our cart for an ATV. For example, if we put on 3 axles, we get a cart for a small truck. 1 axle, say, for a power tiller. You can also change the length, the wheelbase, and other things. But since the end user most likely actually doesn't need this, in other words, a person would need to have a considerable amount of knowledge, various technical tools, and so on to build this model. We moved away from this concept, but the main idea regarding the use of sheet metal, as well as the central sealed capsule, still remains with us. Next, our concept gradually evolved into what became a solid backbone frame, which was originally supposed to be made from 4 mm thick aluminum material. The parts were bent, that's it. And at this point, we also faced a minor setback. Bending aluminum over such a long length, at least with the tools we had available and our equipment, turned out to be quite challenging to accomplish. Accordingly, we once again reconsidered these production risks and moved away from them. And we shifted towards flat metal plates, which are shown in this illustration, so to speak. The entire backbone structure is made of sheet metal assembled using a tongue and groove method, then welded with sealing added using sealant and local riveting. Well, you'll see all of this later in the project. It's still being refined. But overall, that's the concept. In my hands, I have the brake disc of our design, which has its own kind of hub. It's milled on a CNC machine. The disc itself is carefully cut with a precise laser. It's just made from regular, ordinary black metal, simply to work out the design and to fit it properly into the overall construction. Later on, it would be manufactured from a more suitable, high-quality steel material. But, again, for the sake of cost, we ended up with this option. This is also a brake disc from CF Moto. In terms of performance characteristics, it won't be inferior. And also, let's say, the beauty of this disc actually won't be easily visible through the ATV wheel, which has very few openings and almost completely covers the brake disc. So it's not very practical. Let's set this aside and move over here. So in front of you is a mock-up where we're examining some mechanical components. You might ask, why not do this in a program or something similar? But I'll explain. Many of the components we use are purchased parts. Accordingly, drawing them, well, it's not always easy since the geometry of the parts is complex and it's not very practical. So it's easier to do this on a plywood mock-up. We have a machine for this purpose. We quickly put everything together, tried it out, took a look, moved things around, and now we understand how it works, what issues there are, and what needs to be fixed. All these things are immediately visible to us visually. Why, you might ask, aren't we using our own gearboxes? That's a logical question. Because of the price. Surprisingly. Yes, unfortunately, Chinese gearboxes are much cheaper. That doesn't mean they're bad. These are CF Moto gearboxes, basically tried and tested, good gearboxes. That's it. It's just that the price of these gearboxes is much lower, and that will have a positive effect for the end consumer. In other words, you can go and buy such a part at any store. And naturally, it's easier to repair, more familiar, and better known. So in the end, it probably makes sense. For now, we're sticking with them. We'll have another cart that will be subjected to higher loads. We'll talk about that later. Most likely our own gearboxes will be used there. So, what does the wooden mock-up give us? The wooden mock-up allows us to move all our parts around, check the fit, find conflicts between parts, overlaps, and so on. But at the same time, we don't have to draw out the purchased parts. Accordingly, this saves time and resources. We can move things manually, which lets us check the suspension, CV joints, and wheel steering angles. Next, attentive viewers have probably noticed the presence of an electric power steering unit in our system. And you might logically ask, how does our electric power steering work? Our system includes a power converter that steps down high voltage to 12 volts. We'll talk about it in the next episode about batteries. In my hands, I have one of the parts for assembling the control arm. Here you can see our tongue and groove technology. In the next shots, it will be shown in more detail. What does it involve? So we have flat sheet metal. Blanks are cut from it with a laser, and they are joined together quite precisely using the tongue and groove method, since there are no gaps and they fit tightly. After that, the welding process takes place. The welding process wasn't too easy for us. And next, we'll show you the evolution of our lever from the first version to approximately the latest one, though that's not exact. As you can see with the first one, and you might ask what happened to it, we were learning how to weld. Aluminum is not an easy metal to weld, especially when you don't have much experience. We started our welding experiments with a semi-automatic machine. Overall, we managed to do it, but the weld seam wasn't pretty and didn't give the product a marketable appearance. We practiced for a long time and did a lot of experiments. Then, once we had more or less learned to weld with the semi-automatic machine, we moved on to compare it with TIG welding. Accordingly, TIG welding looks better, but takes longer. We actually experimented with the semi-automatic machine because we were afraid of the lengthy process involved in TIG welding. But in our particular case, the comparison showed that the speed was comparable. In some instances, it was even faster than TIG. After that, we ultimately decided in favor of TIG welding and started training to work with it. Our first attempts weren't very pretty, so we decided to remove them using a CNC machine to mill the surface. This procedure seemed time-consuming to us. Our machine is often busy with other tasks, and using it for a production run, well, we ultimately decided against it. So we decided to learn how to weld with TIG properly. Nicely. We gave it a try. We made several attempts. As you can see, the result got better. We put in more effort. For some reason, things didn't go well here. The gas was bad. At some point, it seemed to us that our welds looked good enough and we could confidently paint them in the color that we plan to use for this lever in the future. This is the result we got next. And we noticed small craters at the end of the weld. Well, that's a common thing. It's just that the paint made them visible. We took a close look, thought about it, and realized we wanted it to be better. We practiced with the TIG welder again. It was already pretty good, honestly, but after some consideration, we still decided that we needed a much better result overall, so we turned to a professional grinder for help and advice. The grinder gave us a result of completely different quality. It was achieved quickly. Just in case, we repeated the process. A human is, by its very nature, an imperfect machine, but the result was still the same. When we were completely sure the result was consistent, we performed another paint test, and this time we were genuinely satisfied with the outcome. As you can see, we carefully pressed in the silent blocks. Accordingly, the control arm turned out quite well. This isn't the final design, but the technique was already worked out on this one. If you enjoyed the story about our ATV and want to follow along, subscribe to the channel, give us a like, and stay tuned for the next episode. See you soon.